Hello everyone and welcome to my channel. So today we are going to discuss about aldol condensation. So first let's see what is the meaning of aldol and also what is the meaning of condensation. So aldol is nothing but aldehyde group. You know aldehyde group is CHO and alcohol group is OH. If it's just OH, it is alcohol, and if it's CHO, it is aldehyde. So now you know what is aldehyde and alcohol group. So what is this condensation? Condensation means that in this reaction, we are going to lose one water molecule, and that particular step is called condensation. So together joining the two names, aldol group and condensation of the water molecule. So aldol condensation. So these two together are called combinedly aldol condensation, and this reaction name is aldol condensation. So now you know the base of this reaction, what exactly it is. So now you have to know what is the molecule or compound that we are going to take in this reaction to start with. First of all, you have to take acid aldehyde. Acid aldehyde meaning is that an acid, the definition of acid is that which is able to donate H plus ion. That means acid gives away protons. Protons means H plus. So anything which gives away its H plus ion is called an acid, and which donates an OH minus ion, that is a base. So acid base, you know the basic definitions. So the first compound that we have to take to start with this reaction is that the acid aldehyde, that is CH3CHO. Now you must be wondering why I have written CH3 as CH2 and H. In the next step you will be understanding what is the reason I have written CH3 as CH2 and H. I have divided it into two parts, and this is CHO group, aldehyde group. The oxygen is bonded to carbon through a double bond, and carbon hydrogen is sigma bond, single bond. So this is the starting compound. Now let's take this and treat this with dilute NaOH. This is a base. Generally in these kind of reactions, to liberate water we use dilute NaOH, and in this NaOH, why do we use this dilute NaOH? To liberate the water molecule present in the starting compound. So to liberate water molecule, this H needs another OH, because H2O is water molecule. The compound formula of water is H2O. So OH and H together makes H2O. So in NaOH, OH comes and attaches to this H, and H2O is gone. Now this bond, this particular bond is transferred to carbon, and now what happens to this whole molecule? CH2, this bond is CH2. Since hydrogen with OH went away, now since carbon's valency is 4, carbon is tetravalent, now this bond goes to CH2, and when we gain a bond it becomes minus, and when it donates a bond it becomes plus. So you have to be careful with the signs. And CH2, this bond goes here, and then it becomes CH2 minus, which is attached to CHO. CHO is aldehyde group, and CH2 minus is attached, right? CHO and CH2 minus, this bond goes here, gaining this bond it became minus. So that's why this is CH2 minus CHO, and we call this as carbanion. What is a carbanion? Carbanion is something that which has the negative charge. It is a compound. You have to remember, carbanion is a compound which has a negative charge on the carbon. So here if you see, this compound, this particular compound has negative charge on the carbon atom. Here this is the negative charge. So that is the reason why we call this as carbanion. Anion is negative, cation is positive, as you have studied in your lower classes and in your 11th and 12th standards. So that is the base of that is the basic things about the first reaction. So since now we got nucleophile, why did I call this as nucleophile? As you know, nucleophile and electrophile. There are these two types. Nucleophile is electron rich, we say. It has this, it can able to donate because it is electron rich, and no, electrophile is positive. It is like in a positive sign, it can accept. So that kind of things you have to learn about nucleophile and electrophile. Generally people learn or believe that the nucleophile has negative charge and electrophile has positive charge, and this is a nucleophile. Since this has a negative charge and acts as a nucleophile. So carbanion, I have told you the definition. Compound on which the negative charge is located is called as the carbanion, and it should be located on the carbon atom only. This is located on the carbon atom. So this is carbanion. So now this nucleophile needs a positive center. Nucleophile, since it is a negative charge, so it needs obviously a positive center. So now let's look at the next step. CH2 minus CHO is the nucleophile that we got. This is the nucleophile or the carbanion that we got in the previous reaction. You must have noted down the things that I have written previously, but no problem. I leave the photocopies of what I am teaching in the description down below, so from there you can get a PDF file of my class. So this one reacting with this CH3 CHO, now we have to see what happens, because this whole CH3 CHO thing, what happens, this minus and this carbon is plus. So since this whole minus thing goes and attaches to this plus, this oxygen takes away this bond. As you have to remember one thing here, carbon is tetravalent. That means carbon can have only 4 bonds. So that is the reason why 1, 2, 3, 4, 5. It cannot have 5. If it comes this here, if this whole thing comes here, then you have to attach another bond right here. So if you attach another bond here, 1, 2, 3, 4, 5. 5 bonds are not possible for carbon because carbon is tetravalent. What is tetra? 4. Now, why carbon is tetravalent, you have studied in your lower classes, and then also in my next video I will be telling you why carbon is tetravalent. So carbon is tetravalent. So that's why oxygen goes here, and then what happens in the next step you have to see. CH3 CH, oxygen minus, and coming and attaching to the CH2 CHO, CH3 CO minus, CH2O, and then so CH3 CO minus H, CH3 C, this comes here O minus H, and then CH2 CHO. To this we have to add water molecule, and what happens if we add water molecule we will see now. So till now everything is clear for you. Now what if can I write it this way? CH2 has CH and H, so H and OH, it takes up, water molecule is gone from this beta hydroxycarbonyl compound. I will write again clearly for you. You can understand, right? From this compound actually CH2. So this CH2 only I have written, instead of 2 hydrogens I have written 1 hydrogen up. And since hydrogen got here, it will be OH. And instead of CH2, H went here. So H and OH together goes out as H2O. So that's what happened. And now since water molecule is lost, we have to see what is the, how to satisfy the valency of this compound. Let's see. Since this is the compound CH3 CH OH CHH and CHO, and in this compound I have taken out the water molecule. So now what is left? CH3 is left, CH is left, CHO. Is this the right thing? No, this is not the right thing, because carbon's valency is not satisfied. One bond, two bonds. Okay, to clearly understand, I'll show you carbon's valency here. Carbon, hydrogen, right? So hydrogen, 1, 2, 3. What about 4? Another hydrogen should be there, but no hydrogens we got, so another bond. Again, 1, 2, 3. So what about 4? Another hydrogen is there, right? So H. CH3, CH. CH3, CH and CH, CHO. Everything is same. We have satisfied the valency of carbon. So that is why this compound's name is that enol. What is enol? En means double bond. Alkene, double bond. Al means aldehyde. So CH3, CH, CH, CHO is the final compound, and this is called actually aldol. You know aldol. Why it's called aldol? Because aldehyde is there, alcohol group is also there. So that is the reason why it is called as aldol. So let's see further what happens next. So here you must have got a doubt that why hydrogen is being removed from this alpha carbon only, because in hyperconjugation we learn that more the number of alpha hydrogens, more the stability. So that is why the hydrogen is removed from this alpha carbon, and hydrogen is removed from this alpha carbon, and OH is removed from the beta carbon. What is alpha hydrogen? Alpha hydrogen is the hydrogen which is attached to the alpha carbon atom. Now, what is alpha carbon atom? The carbon atom which is attached to the functional group is called the alpha carbon atom. Here the functional group is CHO, and this CHO is attached to this carbon atom, so this is alpha carbon, and the hydrogens attached to this alpha carbon are alpha hydrogens. So that is the definition of alpha hydrogen, alpha carbon. And now you must have understood this condition is that alpha hydrogens are must for aldol condensation. You have to remember that. Why we have removed hydrogen from this position only means in hyperconjugation we say that more the number of alpha hydrogens, the greater the stability. So here if you see, this is the functional group. Double bond is a functional group. Triple bond is also a functional group. So it is double bond. Functional group attached with carbon. So this is alpha carbon, and this has hydrogens attached to it. So this whole thing is a functional group. And the carbon which is attached to the functional group is that CH3. It has 3 hydrogens. So that is the reason why hydrogen is removed from this place rather than removing from this place. You must be thinking that why can't I remove hydrogens from 2 hydrogens from here and then 1 oxygen from here? No, you should not remove like that, because it reduces the stability of the compound. So that's the reason why I have removed from hydrogen from alpha carbon and hydroxyl OH from beta carbon. So that's the reason why I got this final compound enol. And I'll rub the board and write the final product for you again so that you will get a clarity. CH3, CH, double bond CH, CHO. So this is the final compound. You can call it as butanol, enol. Why it's butene? Because 4 carbons. So this is the final product of Aldol condensation. So that's all for today's video. If you have any doubts in this aldol condensation topic, you can always ask me in the comment section down below, and I'll definitely clear your doubt within 24 hours. And also, if you want to have the notes of this aldol condensation, I will give you in the link in the description down below. You can get my handwritten notes. And if you like this video, please like the video. And also, if you want to share this to your friends, please subscribe to my channel and also share it to your friends, saying that it can be helpful for you since you are preparing for competitive exams. This will be very helpful. And yeah, that's all for today's video. Next time I'll be meeting you with why carbon is tetravalent. Thank you very much.